right, this is synthetic substitution. So this is super, super easy. Maybe one of the easiest things we do all semester.
Yeah, it is.
And you should have some basic knowledge of it, but it just depends on what class you had and when. So, at the very top, it says, if f of x is x cubed plus 6x squared minus 9x minus 14, find f of 2. Now, with our calculator, we could just plug 2 in. When they write this, f of 2, what do they mean? X is 2. They want you to plug 2 in for x. So yes, could we do that on our calculator super fast? Of course we could. And you can do that to check yourself if you would like. But really, this serves a much bigger purpose than just for synthetic substitution. It comes back several times, but in this unit it's going to become really important. So we need to know the process of synthetic substitution instead of just plugging it into our calculator. So the first step is to write the coefficients in order according to descending powers. So on the quiz that you just took on Delta Math, when it was asking you end behavior, were your functions in correct order with descending exponents?
No.
They were not. So you got to be careful, check and make sure that they are in descending order because you need your coefficients in descending order. The other thing that's important is you need to make sure that you have each one. If you don't, you have to have a placeholder. So whatever exponent it starts with, the degree, which in this case is 3, I have to check and make sure I have a 3, a 2, a 1. You don't have to have a constant, but then the constant would be next. So I have a 3, a 2, the 1 of course is understood, so that's just the x, and then a constant. So you got to make sure that they're in order and that you have all of them. If you don't have them all, you put a placeholder. We write down just the coefficients. So the coefficient of x cubed is just 1. There's an understood 1 in front of that x cubed. So I write down a 1, a 6, a minus 9 or a negative 9, and a negative 14. So that's your first step. You write all of those down. And then the x value that you're substituting in, you write that in this little box to the left-hand side. Second step, bring down or copy down or drop. I usually say drop the very first lead coefficient, so I drop the 1, and then you multiply, add, multiply, add, multiply, add until you are done. So I take this 1 and I multiply it by what's in the box. 2 times 1 is 2. Then I add straight down. 6 plus 2 is 8. Then we start all over again, multiply, add. So 2 times 8 is 16. Add straight down and you get 7. Then you multiply. 2 times 7 is 14, and you add straight down and get 0. So, whatever is left at the end, that is what f of 2 equals. And you can plug that in your calculator and check to see if it is in fact what f of 2 equals, and it is. So they ask us to do the same function. So I'm going to go ahead and put this, since we're going to do it again, the same function, I'm going to go ahead and put it in my calculator so we can check our work. Let's see, x cubed. Alright, so if I go look at my table, I can look at where x is 2 and see if I got and right there at x is 2, it is 0. Alright, so the next one that they asked me to do is the same function with the same coefficients, negative 1, 6, negative 9, and 14, and they want me to find f of 3. So 3 goes in the box. I drop my lead coefficient, and I'm going to multiply. 3 times 1 is 3, add straight down, and get 9. Multiply, 3 times 9 is 27, add straight down, and get 18. Then 3 times 18, 54, add straight down, and you get 40. So that means f of 3 equals 40. So I'm going to go to my calculator, check my table, and sure enough, f of 3 is 40. Now, this really comes in handy at times where you can't use your calculator because this is a whole lot easier than just plugging in. If I was going to plug 3 into this function up here, I would have to cube 3 and then square 3 and then multiply. So this is a lot easier process than that. So it comes in handy a lot when you don't have a calculator to use. do the same thing with negative 7, so I put negative 7 in the box. My same coefficients across the top, 1, 6, negative 9, and 14, negative 14. Drop the 1, negative 7 times 1 is negative 7, add straight down, you get negative 1. Negative 7 times negative 1 is positive 7, add straight down, and you get negative 2. Negative 7 and negative 2 is positive 14, and you get 0. So if we go to negative 7, I should get 0, and I did. So, voila. So far, so good? So they've given me a new one down here. This is a new function. So again, I have to check and make sure. My degree this time is 3. So before we solve this, let me ask you a couple questions about this. Since its degree is 3, what can you tell me about its end behavior? What's happening at the ends of this graph? It's going to, which side's doing what? What's the end behavior of this cubic function, number 1?
Should go up, or, sorry, as x approaches positive infinity, y approaches positive infinity.
Yep.
As x approaches negative infinity, y approaches negative infinity.
Very good. It goes like this. It's cubic, which means it's 1 up, 1 down, and it's got a positive lead coefficient, so it's rising to the right. Okay, so I have all my coefficients, and they're written right here, so I drop the 1. 1 times 3 is 3, add straight down, you get negative 3. 3 times negative 3 is negative 9, add straight down, you get 1. 3 times 1 is 3, add straight down, you get negative 5. So f of 3 equals negative 5. So far, so good? Okay. Same function, so same lead coefficients, 1, negative 6, 10, and negative 8. This time we're doing f of 4, so 4 is in the box. Drop the 1. 4 times 1 is 4. Add straight down. You get negative 2. 4 times negative 2 is negative 8. Add straight down, and you get positive 2. 4 times 2 is 8. Add straight down, and you get 0. So f of 4 equals 0. Now on number 3, it's a new function, and they stopped giving me the little box. That's okay. You can make your own. Make sure you have all your descending exponents and that everything's in order. So the highest exponent, or the degree, is 3. 3, 2, 1 constant, so I'm good. So I've got a 2 in the box because I'm looking for g of 2. My coefficients are 2, 1, negative 41, and 20. So you drop your lead coefficient of 2. 2 times 2 is 4. And then you just add straight down. 1 times 4 is 5. Or 1 plus 4, sorry. 2 times 5 is 10. Add straight down. And then 2 times negative 31 is negative 62. Add straight down. So, oh, this is g, sorry. G of 2 is negative 44. Everybody good? All right, do 4 and 5 real quick.
in it, we got number 3 wrong, it's, negative 42.
Oh, you're right, because 31 times 2 is 32, is 62. I think I even said 62 and I wrote 64. Thank you.
Looks a lot nicer than some old toy.
It does, turns out it. Alright, did y'all get h of negative 2 is 50 and h of 8 is 0? Okay. So that's what's funny. Number 6 isn't any different, it's just that it has a fraction, so I just want to make sure everybody's okay if we're doing it with a fraction. It's the same thing, so shouldn't be a big deal. 1/2 is what goes in the box. And across the top you have 2, 1, negative 41, and 20. So drop the 2. Remember, multiplying by 1/2 is the same thing as dividing by 2. 1/2 of 2 is 1. 1/2 of 2 is 1. 1/2 of negative 40 is negative 20. So I got g of 1/2 is 0. Alright. Alright, on 7 and 8, they're just getting a little bit longer. So these are no longer cubic functions. These are what we call quartic functions. They're to the 4th degree. So if they're to the 4th degree, what's the end behavior of a 4th degree polynomial? What can you tell me about the ends of number 7?
They both go up.
They both go up. It's to the 4th degree, which means the arrowheads do the same thing. As long as the degree is even, the 2 arrows are doing the same thing, and the lead coefficient's positive, which means it's rising to the right. Both ways. All right, 3 in the box. 1, 5, 10, 20, 4. So, in the middle of the page, they've got another one. m of x, and they've got 3x squared minus 7. So I have, it's a quadratic. The highest exponent is a 2, but I am missing x to the first power, or the linear, what we would call the linear piece, the one that's just x. So it says to use synthetic substitution when terms of a certain power are not present, a coefficient of 0 must be used to fill the place. You have to have a placeholder. For example, the coefficients 3x squared minus 7 are really 3, 0, and negative 7 because we're missing that x term. So make sure that you always check for that. If you don't, it will mess you up. And the problem is you won't know because all we're doing is multiplying and adding. And so sometimes the numbers get big and you won't know the difference. So always make sure that you check that. So on number 9, my degree is 3. It's cubic. So I should have a 3, a 2, and a 1, but I don't. I have a 3 and a 1. So I have to put a placeholder where the second degree would go. So I'm putting negative 3 in the box, and my coefficients are going to be 2. That's my third degree coefficient. 0, because I don't have a second degree coefficient. Negative 14 and 16. And then the process is exactly the same. So drop your 2, multiply, add straight down, multiply again, add straight down, multiply again. And I got f of negative 3 equals 4. On number 10, I've got, it's the third degree polynomial, so I should have a 3, a 2, and a 1, and then a constant. Well, I have a 3 and a 2, but no 1. That's where I'm plugging in a 0 for a placeholder. So 3 goes in the box, negative 2, 4, 0, 23. So I get a of 3 equals 5. Everybody okay? All right, so number 11 is quartic, so it's to the fourth power. So you should have a 4, a 3, a 2, and a 1. I am missing my second degree coefficient. So 4 goes in the box. 4, 3, 2, 1.
Whenever you multiply that by a fraction, don't you just divide by
Half of 4 is 2. All right, last one on the page, on this page, on the notes page. It's a quartic to the fourth degree. I am missing the third degree and the first degree, which means I've got 2 placeholders this time. So negative 4 goes in the box. So 1, 0, negative 17, 0, and 16. Drop the 1, then multiply. Everybody good?